All right, so Mole Day is Saturday, October the 23rd, and it celebrates the mole and chemistry that we use all the time. So I'm offering you a little project that you can do. It'll be due the Friday before, October 22nd. And you're going to make a mole and you're going to give him or her a story. So they would be dressed, have accessories that would go along with that story. You need to write up their little life story and be prepared to present it to the class. It doesn't have to be pages long, just a good little pages usually does it. And then within the class, we'll vote for like the most creative one and they'll get extra points. This is 5 points added to your 6 weeks average, not just to a test grade. So if you have a 6 weeks average of 95 and you did this correctly, you would bring it up to 100. So this is a good way for somebody that failed last 6 weeks to recover some points. So they'll end up passing for the semester. If you have any other ideas that you would like to do for Mole Day, then you can get with me and we can see if they'll work out and I'll let you know how many points that they would be worth. Don't just come up with your own idea and be here on Friday, the 22nd to present it because you won't get any points for that. And this is an all or nothing situation. So like you're either do it correctly, make your mole completely, give them the story, present, you get 5 points, or you don't get any. There's no in between or partial points on anything. Does anybody have any questions on that? Okay, I have some pictures that I had pulled up. Let's see if I can steal to see if you, so like examples of these, I've had like a molarina instead of a ballerina, a molarina. I've had a guacamole, like instead of guacamole, a guacamole. The year that Johnny Manziel won the Heisman Trophy, I had a Johnny Moselle. So those are kind of some ideas. Yeah, that was before I did this. Actually, it was my daughter when Mrs. Parker taught it. So these are just some examples. So your little pattern, you make them oftentimes with felt, and then you give them a little story. I'm sure this is probably Santa mold. I have had stuff with Starbucks before. I've had all different kind of stuff. Yeah. Down here. And I had one other picture somewhere. So these are some other pictures. Like, yeah, like this one probably is Nemo. Maybe. Does that look like Nemo? No. Okay. Okay. As I said that, I was like, I don't think that's right.
I like that one. That one with the cater saying.
Yeah, like I feel like this one might have been like guacamole, you know, fiesta kind of thing. Super mole.
That one's cursed.
Yeah, I don't know what the black one is. He's got covered with something else different. Anyway, so you kind of get some ideas. So that'll give you, the only thing I can't do is go above 100. The computer won't let me. So like last year, Aaron Dean got to get a 97 and they did this. I would only let me put up to 100. Well, let me put 102 as the computer. So, all right. Anybody have any questions on that? All right. So that gives you a little bit of time to figure it out. A couple of weeks. All righty. If you will get your notes out. We are going to move on. Yes. So if you look on your practice on the front side, down one side, it tells you what kind of problem it is, which will make more sense as we start moving along. And if you see a number underneath it, it tells you how many steps it is, which will also make a little bit more sense as we move along. And then on the second page, then I don't have any of that because you will have hopefully kind of caught on and worked on that. The quiz won't have how many steps or anything like that. You'll have to be able to figure that out. So hopefully you watched the video and it may give you a little bit of a head start. on what we're going to be looking at. And like I said, this is actually going to end up being 2 days of notes. I thought I could get through it one day, but I couldn't, so that works. So we're going to be using dimensional analysis and conversion factors that have to do with the mole as we do our problems here. And our conversion factors that we're going to use are going to be molar mass, which is grams per 1 mole. And then the other one we're going to use is Avogadro's number, which is 6.02 times 10 to the 23rd particles per 1 mole. And when you use a conversion factor, they can be flipped because they're equal. When you do molar mass, it's like writing a 1, just like if you said 2 over 2 was equal to 1. It doesn't look the same because there's different units, but that's how a conversion factor works. So I may need it sometimes grams per mole, and then sometimes I may have to flip it and need it as moles per gram. And we're using dimensional analysis, which we've done a little bit before in conversions. So dimensional analysis is when you set up a system of like boxes, or sometimes you'll just see it as lines with multiplications in between them. I tend to use this method where I set up boxes. So when we do that in our dimensional analysis, we're always going to start with our unknown, unknown here. We're not going to have anything in that box below, and the unknown always determines our sig fig. And then at the close, let's say that our equals sign is here. At the top closest to the equals, we're going to put our known, or what we're trying to, I'm sorry, I just did that completely backwards, y'all. Let me try that again. That's what happens to me by the time I get to 8th period. It would be make much more sense if we started off with our known and we're trying to get to our unknown. So within these boxes, we're going to be using different conversion factors. Molar mass sometimes, Avogadro's number sometimes. When you do your dimensional analysis, once you have them all set up, you're going to multiply across. So in other words, I would multiply this way. And multiply if I had a bunch of things all on the bottom. And then you're going to divide your top by the bottom. And so usually this can be done in one step in your calculator. And you know, y'all are usually better at the calculator than I am. But if you're having a problem with that, then we can work on that as you do some problems. All right. So like I said, we're going to be using the mole as both of those conversion factors. We define mole as 6.022. We're just going to use 6.02. I'm not going to use double twos, will be okay. Times 10 to the 23rd atoms of a pure element. That would be a type of particle. Or if we're dealing with the molar mass, and that's how many grams there are within a mole of that compound or that element. I'm going to tell you a list of diatomic molecules which you need to memorize. Bromine, and when I put a subscript, I'm putting a subscript of 2 with each of these. So bromine, iodine, nitrogen. Yes, sir. Chlorine, hydrogen, oxygen, and fluorine. Those are called diatomic molecules because they're not stable as just one atom. They either have to be bound to another atom just like themselves to make a molecule, or they have to be within a compound. So when these elements are by themselves, so not part of a compound. They exist as two atoms together, which would be a molecule. And you need to memorize these because we use them all year long. And if you like a mnemonic, the mnemonic for these is Brinklehall. BRINCL gives you your Brinkle. HOF gives you your Hoff. So for example, if we were making hydrochloric acid from hydrogen and chlorine, here, these atoms are by themselves, they're not part of a compound, so they have to exist as a diatomic. But then once they form a compound, there's not necessarily going to be two of them. They're stable now because they're part of a compound. And the reason that becomes important for things like nitrogen gas or oxygen gas, it affects the molar mass. Because if I talk about nitrogen gas, I'm talking about two atoms of nitrogen, not just one. So that's why they become important. One little bug that keeps firing. All right, anybody have any questions on that? All right. When I get finished, you can. Okay. So this is a mole map. I like dimensional analysis. I'm nerdy that way. Like some of y'all may be nerdy because y'all like Star Trek or Harry Potter. That may be your nerdy moment. My nerdy moment is I like dimensional analysis. If you don't like dimensional analysis, the mole map is a way to get around that. So for instance, the way this works, let's say that I knew how many moles I had. That was my given. And I wanted to find out grams. So instead of doing that through dimensional analysis, you could do your mole map. So you're going from moles to grams. So to get there, I would take my moles, I would multiply it by the molar mass, and that would give me my mass in grams. Or if I was going the other way, if I was given mass and I wanted to find out how many moles, now I follow it this way. So I would take my mass and I would divide by my molar mass and it would give me moles. So this is just a way of not keeping up with units, which is important in dimensional analysis. You're just kind of dealing with the numbers, but you have to know what you're starting with and then you have to know what you're ending with. Don't worry about this part down here where it says ideal gas because we don't get to that till way later on. But on the other side, same thing. If I had moles and I wanted to know the number of particles, let's say the number of atoms, then I would follow it and take my moles, multiply it by Avogadro's number, and that would give me my number of particles. So it's just a way to kind of get you around, around dimensional analysis. So this 120 grams of calcium, that's already worked out for you. I'm not going to work that out again. So I'm going to use this little section to just kind of to do some notes. So when I see a problem, a word problem, things that we need to look at, we want to look at type of problem. I think I got it. So like whether it's a mole to mass or mass to mole, because the type of problem is going to tell us how many steps it is. I want to think about what conversion factors I'm going to have to use. If I see within the problem grams or mass, that tells me I'm going to have to use a molar mass as a conversion factor. If I see some type of particle, remember that could be an atom, it could be a molecule. If I see some type of particle, then that tells me that I'm going to need to use Avogadro's number. Jackson, I can tell you that if you have your phone out, which you do, and you're texting instead of taking notes, I will take it up from you and I will turn it in. Okay, well then next time you say, my mom needs to know something, I say, okay, Jackson, then answer your mom. That's all it takes. Okay, and then the other thing that you're gonna wanna look at is sig figs. That comes from your given. We'll do some problems where we have to use molar mass and Avogadro's number. Those are the long ones for right now. Those are 3 steps. So these are all the things that when you see a word problem, you're gonna kind of want to dissect. Yes, sir, we are. All right, so with that being said, let's start with our first one. All right, so my first one says, how many grams of sodium, and I'm going to change that to sodium chloride, are in 5 moles of sodium chloride? So I look here and I say, okay, my given is that I have 5 moles of sodium chloride. And my unknown, what I want to get to is grams of sodium chloride. So this is a mole to gram problem. It can be gram or mass. My given is in moles. I want to get to a mass. I want to get to grams. And those are 2 steps. And this is what I call 2 steps. I call 2 steps 2 boxes. Okay. So I see the word gram within that problem. So that tells me I'm going to have to use a molar mass as a conversion factor. And then the last thing that I look at, I see, okay, my given has 3 sig figs. So I'm going to want my answer to have 3 sig figs. Okay, so those are kind of all things that I look at to start off with. And once I've kind of thought about that, then I get myself going. I always start with my given at the very beginning, 5 moles of sodium chloride. Like I said, we're not putting anything right here. And then I want to go at my top closest to my equals with what I'm trying to convert to, which is grams of sodium chloride. I like to give myself a beginning and an ending. Once I do that, I have to start following my units, because for dimensional analysis to work correctly, you have to cancel out all your units until you're left with just one. So if I have moles of sodium chloride here, I have to have the same thing down and diagonal. So I need moles of sodium chloride down here. Same unit, mole, and same compound or element. All right, so now I need a conversion factor. Since I see grams, we said that's the molar mass, so I would have to find the molar mass of sodium chloride, which you could do in your calculator, but I'm going to just work it out here this time. So I have 1 sodium and 1 chloride. Sodium is 22.99 and chlorine is 35.45. Running out of space. Add them up together and I get 58.44 grams per 1 mole. So just like we were doing with our molar mass. The 58.44 stays with the grams, so I would come and put that up here. And the 1 stays with the moles, so that would go down here. My moles cancel out like it should. I'm left with just grams of sodium chloride, which is what I needed. So I am going to multiply, just like Jackson said, 5 times 58.44. I would divide by whatever on the bottom, but since we just have 1, do I have to worry about really dividing by 1? No. 3 sig figs when I get my answer. Perfect. 3 sig figs. So 292, right? 292 grams of sodium chloride. No, because it's not a 0. Yes, sir. Yes. Okay, well, I'm going to do another one, and I'm not going to call you out, but if you did not watch the videos over the weekend that I assigned, since we're going to be working on this continue tomorrow, I would really recommend going back and watching, just to reinforce it. Okay, but I'm going to do another one right here, and then I'll let y'all try one. Which, is there any particular part like where I can answer a question, or would you just like for me to work through another one? Okay. This part right here where I started with, that's always going to be your given. So since my given was 5 moles of sodium chloride, that's why that would be. So you're always going to start it out with what you were given in the problem. All right. Anybody else have any? In fact, let's, instead of doing the next one, let's jump down to the third one. It'll be a little bit different. And then y'all, we can still come back and do the second one. All right. I'm going to have to write it because my PowerPoint was messed up, but y'all should have it. I'm just going to jump to the last one. How many? The last one on that page, I'm sorry. Moles of, oops, that's not how you spell of. Nitrogen are in 44.0 grams of nitrogen gas. All right. All right. So I'm going to look at what I have. I'm given 44 grams of nitrogen gas. I want to get to moles of nitrogen. So this is a gram to mole problem, which is still 2 steps. And that part right there, those are things you're just going to learn the more you do and kind of memorize that. Like y'all wouldn't necessarily know that right away, right now. One, it's just kind of seeing some of them and practicing.
It has to be specific, that's what we want.
Well, yeah, this one happens to be 3 sig figs because it's always based off of what your given was. So since this is 3 sig figs, yes, your answer would be 3 sig figs again. All right, so we said it's 2 steps. I see the word gram in there, so that I know that means I'm going to have to use a molar mass as the conversion. So we are not doing anything with Avogadro's. I don't see atoms or molecules, no type of particles. So we start, we're going to give ourselves 2 steps. I start with my given, which is my 44 grams of nitrogen gas. So somebody tell me what I'm going to write down for nitrogen gas, because I don't want to write the word nitrogen. Into, thank you, because it is diatomic. So it's going to be into, so that's why you have to memorize your diatomics, because if you put just in there, it's going to mess you up. And I want to get 2 moles of nitrogen. All right, so since I have grams of nitrogen here, I have to have grams of nitrogen down here because I need them to cancel. Yes, ma'am. What do you mean? I'm not following. I'm sorry.
Like you wrote mole above into.
Yes.
Does it have to be above?
Yes, it does. But I'm right. This, y'all don't need to write the circle, but that is a conversion factor right there.
No, like when you're writing it down, like just mole into.
You may have to show me in a minute, okay? Because I'm not following. Sorry. All right, so we had grams of N2. So I see grams down there. So that means I need my molar mass. So what's my molar mass of 2 nitrogen? 28.02 grams per, is always per 1 mole of the same compound. So grams canceled out. Now on this one, I'm going to do 44 times 1, which keeps it at 44, and then come back and divide by 28.02. And we said 3 sig figs. So what did we get? I got 1.57 moles. You didn't just, it should have just been 44 divided by 28.02, Jackson, was all you would have needed on that one. Because multiplying by 1 wouldn't change it. All right, y'all tried to do the one in between. Y'all tried to do number 2 on there and see if you can get it. And I want you to show me if you don't mind. And we will continue on tomorrow. Oh, my nose.